When you think of energy, what comes to your mind? I think of my kids who have so dang much of it. But for many people, the first thought might be the lack of it, or man, I wish I had more of it. Well, if this is you, you may want to keep watching. We're going to look at all the ways H2 may increase your energy on this episode of H2 Minutes. Energy, the stuff that helps you get up and go. We get energy because of a little molecule called ATP. ATP stands for adenosine triphosphate. It is known as the energy currency of the cell. ATP pays the bills to keep you moving. ATP is used for a multitude of cellular functions. When ATP is broken down to ADP, energy is released. This energy is what drives many cellular activities. If you want to know more about ATP and energy production, I have provided a couple educational sources in the description. Now let's get to the H2. H2 can potentially increase your energy in not just one way, but 5 ways. Of course, with all the work still left to be done in hydrogen research, there may be many more ways that H2 can increase your energy. But for now, we just go with the top 5 ways that the research is suggesting. Number 1, one of the most documented benefits of molecular hydrogen therapy is its ability to reduce oxidative stress. The hydrogen molecule has been shown to be a selective antioxidant, only neutralizing the cytotoxic free radicals, including the hydroxyl radical and peroxynitrate. Because H2 is the smallest molecule in the universe, on top of being neutral, it has the highest diffusion rate out of any molecule or antioxidant. What this means is that H2 is able to enter all parts of the cell, as well as all organelles and the nucleus. This also means that H2 can reduce oxidative stress within the cell and the mitochondria. This helps the mitochondria perform more efficiently, which leads to either an increase or a maintaining of normal ATP production. Let's take a look at some quotes from these sources. ATP levels directly reflect mitochondrial activity, and several reports have suggested that hydrogen can protect the mitochondria from damage. Hydrogen can penetrate the mitochondrial membrane, prevent the decline of mitochondrial membrane potential, and protect the mitochondria from ROS. In addition, hydrogen saline markedly increased the antioxidant potential of mitochondria, as evidenced by elevated ATP levels. In conclusion, hydrogen saline attenuates mitochondrial oxidative stress and dysfunction, and inhibits mitochondrial-mediated apoptosis. Number 2, research has shown that H2 can stimulate or increase the expression of the metabolic hormone FGF21. This has been demonstrated by H2 stimulating the PPARA pathway. FGF21 is a liver hormone that can increase cellular metabolism, which can aid in weight management and increase energy. To quote this study, to examine how drinking H2 water improves obesity and metabolic parameters at the molecular level, we examined gene expression profiles and found enhanced expressions of a hepatic hormone FGF21, which functions to enhance fatty acid and glucose expenditure. Indeed, H2 stimulated energy metabolism as measured by oxygen consumption. The present results suggest the potential benefit of H2 in improving obesity, diabetes, and metabolic syndrome. Number 3, there is evidence that H2 has the potential to upregulate ATP production by stimulating the electron transport chain, including all 5 complexes. The electron transport chain is just the main mechanism the mitochondria uses to produce ATP. As you can see by this graph, hydrogen water was able to stimulate all the complexes of the electron transport chain beyond the regular water. To quote the same study, drinking hydrogen-rich water increased mitochondrial function in the allograft and prevented the loss of mitochondrial complex activity. Thus, hydrogen may directly protect the mitochondria and thereby restore mitochondrial energy metabolism, especially fatty acid metabolism. Oral intake of hydrogen-rich water resulted in significantly higher ATP levels in the allograft as compared with the allograft from rats that drank regular water or distilled water. This benefit was even shown when the mitochondria were damaged or compromised. Number 4, H2 might stimulate ATP production independent from the electron transport chain. This happens via the Jagendorf reaction, which means H2 could be causing a proton gradient and thus stimulating ATP production outside of the electron transport chain. Let's look at a couple quotes from this study. Thus, this works provides evidence that molecular hydrogen can support ATP production independent of the electron transport chain. We propose that these findings can all be explained by the Jagendorf reaction, defined as ATP production that results from an inequality of hydrogen ion electrochemical activity that has been produced independently of the electron transport chain. In parasites in which the electron transport chain was inactivated, ATP levels were found to be elevated. We propose that molecular hydrogen may also be producing a hydrogen gradient, thus promoting mitochondrial ATP production independent of the electron transport chain activity. Finally, we found that molecular hydrogen water preserved or increased ATP levels and proposed a new mechanism for molecular hydrogen water, that of ATP production through the Jagendorf reaction. Further research needs to be done on this topic, but it appears to be another remarkable benefit of H2. Finally, number 5. Not only does H2 reduce oxidative stress in the mitochondria, but it also appears to promote mitochondrial biogenesis. Basically, it seems to help our cells make more mitochondria, which is the powerhouse of the cell. H2 appears to be able to do this by stimulating the PGC1A pathway, which acts as an organizer for mitochondrial biogenesis. So, the more mitochondrials, the more opportunity for ATP production. To quote these studies, PGC1A also functions as an organizer of mitochondrial biogenesis. Recently, it was reported that H2 enhanced mitochondrial membrane potential in damaged sperm. Multiple functions of H2 may be elucidated at least partly through multiple functions of PGC1A. Preconditioning lung grafts using inhaled hydrogen attenuated these pro-inflammatory changes, promoted mitochondrial biogenesis in the lungs throughout the procedure. Restoration of ATP levels in the allografts in recipients that consume hydrogen-rich water likely results from increasing the number of mitochondria in the graft and sustaining mitochondrial respiratory function. Now, all these things may sound complicated, and they are, but the main thing you need to know is that H2 has the capability to give you more energy in multiple ways. So fill up your glass, drink some H2, and let's go to work. That's your dose of H2 in 2 minutes.